Yo, it'd be here in Phoenix. Yeah.
You gotta talk louder. Okay, so this is geometry. So we're actually doing two column proofs. So we're starting with, okay, we already did a couple definitions and stuff. So some other postulates, right? Yes. Okay, so kind of gotta speak up. The microphone's over here, so.
What?
So,
Go to the front.
oh,
ASMR
anyway,
video, Pacho.
Anyway, all right, okay, so you guys ready? So now, these are all the things that we've had so far. We added a whole bunch of properties, postulates, and all kinds of other stuff, and definitions. So we did that. There we go. Okay, there we go. It wasn't lined up right. Okay, so now this is one we worked on yesterday, right? Yeah. So I'm going to start from the beginning. Okay, so I'm going to start from the beginning. So this should be, everyone should have this part right here, right? Yeah. So class.
Yo,
Okay, what's my first step all the time in my two column proof? Given, thank you. So right here I'm going to go 1, and it's going to be E is, there we go, midpoint of A, C, and B, D. Okay, so that was my given. There you go, so there's my given. Okay, so now, remember we were talking about sandwiches yesterday, right? We were talking about sandwiches, and so if you go halvesies on a sandwich, you expect when someone cuts that sandwich, it's going to be 2 equal halves, right? But where are we going to cut it at?
The middle.
The middle, or also known as the midpoint. Thank you. That's what I'm looking for there. So I'm looking at the midpoint for this one right here. So we know E is the midpoint of these two pieces. So now, let's take a look. So my first sandwich I have is AC. So my congruent parts are going to be what? AE and EC. Very good. So that's my first part because that's part of AC. So 2 is going to be AE is going to be congruent to EC. And thank you, definition of midpoint. Okay, so now that took care of my AC. That's that sandwich. Now we just went to a different store. We're going to go to Jersey Mike's now. Okay, so now we have DB. Okay, so again, we have Z's on that. So we cut it at the midpoint. So what do we know?
DE is congruent to EB.
Excellent. DE congruent to EB. And same reason as definition of midpoint. So this is kind of where I left off yesterday because I ran out of time. So let's take a look. So now I have those. I'm going to put in my markings right there and right here. They have different markings because I don't say that they're congruent to each other yet. All right, so now what else am I missing? My second given, right? I have more than one given in this statement. So my second given. So I'm going to put my second given up there. So 4 is going to be ED is congruent to EC, and that is my other given. So let's do the markings on that one. So it says that EC is congruent to ED. So this one has 2 marks. This one has 1. So what am I going to do to EC?
Add another mark.
Add another mark, right? So now those are congruent now, right? Because that was given to me. And now because these 2 are congruent, what do I have to do to AE?
Add another tick mark.
Add another right there. So now they all have the same tick marks. Now I have to give it in a statement. I have to make a statement about this. So now I'm going to use a special property for this one. So to see if you guys could follow along on this one. So for 5, I'm going to say that AE, said AE and I still didn't write AE. So AE is congruent to EC because I have that, right? And EC is congruent to ED, then I could state, so given those information, what do I know? What else could I state? A, very good. AE is going to be congruent to ED. And my step 5, my reason for that one. Transitive. There is my transitive, right? Transitive property. So I have transitive property there. Now, I'm going to go with another statement. So now, because I know that AE is now congruent to ED, okay, but ED is congruent to what? EB, right? It's going to be congruent to EB. So I now have it that it's going to be congruent to EB. So I'm going to make a statement now. So I'm going to end this one. So it's going to be here. So I'm going to say that AE is going to be congruent to BE, because I have that AE is congruent to ED, right? Yes? Yeah. Okay. And I know that it is, did I mess this one up? EC. Where did I mess that? EC. And then EB. Because BE is congruent to DE. And I already have that this is congruent to DE already. ED and DE mean the same thing. So even though I have it written backwards, it means the same thing. So I'm going to state that these two are now going to be congruent. Now, I took this statement right here. Okay, I took this statement right here. Where's that? This statement right here. I thought I just selected red. Come on, come on. You can do it. You can do it. It's all up to you. There, okay. So, this statement right here, and I'm going to replace ED, just this piece right here. I'm going to replace ED with what I'm looking for right here. Because ED is congruent to EB, or BE. So, since this, I'm going to replace ED, DE, with EB because it's already there. These pieces are congruent to each other, right? Yes, these two are congruent to each other. So now I'm just going to replace using this statement. So it's now AE is going to be congruent to BE, and I'm getting that from this statement over here. So it's going to be my last statement, since it's going to be a replacement. It's going to be a replacement. Now, which property do I use? Substitution. There we go. Now, substitution was on that first page I gave you with the properties, right? It was the one with the algebraic properties. So, substitution property of equality. Okay, kind of makes sense a little bit. Okay, we're going to do more of these. Okay, let's try another one then. Okay, so now we have several givens again. I have 3 givens in the statement. Okay, 3 givens in the statement. So we're trying to prove this statement right here. We're trying to make this piece true. So class, yes. What's my very first statement? Given. So I'm going to start with my first one. So OB, it's ray OB bisects angle AOC. Now, all right, you guys. Now, the word bisect. What does the word bisect mean? I heard it over there. Cut in half. Cut in half. Is it exactly half?
Yes.
Yes. Okay, the definition for that is cuts into 2 equal parts. Okay, 2 equal parts. For bisect, it's always 2 equal parts. Okay? Yes, it is in half, but I need to actually, that statement of 2 equal parts. So, given this right here, OB bisects AOC. Now, trace, let's see, AOC. If it bisects it, so what do we know about AOB? Congruent to? BOC. Very good. That's what I'm looking for. Right here is congruent to right here. So that's from this given right here. Okay? From that given, so now let's make that statement. Let's make that statement now, because I already used that information. So now 2, I'm going to say that angle AOB is congruent to angle BOC. And what is the reason that I just got for that? I heard it. Definition of what? Yes. Definition of angle bisector. Okay. So I'm going to abbreviate this further, so it's going to be just definition of bisect. Because we're going to have line bisecting and angle bisecting. So a valid reason will be, definition of bisect. Okay? So that's very good. So now let's go with our next given. So if I go with my next given, it's going to be 3. So my next given is going to be ray OE bisects angle DOF. Okay, so now that's going to be a given again, right? Let's go over here to the drawing, to my little sketch right here for this. So now, if it says that AE bisects angle DOF, what do we know because of that? EOF, and EOD are congruent. Very good. That's what I'm looking for. So because of bisect, I now know because of that. Bisect means cut it into 2 equal parts, and I'm marking my equal parts now. So that's going to be my statement 4. It's going to be angle there we go. So that's FOE is congruent to angle EOD. Definition, bisect. Okay, so I have a lot of information up there. Now, what else do I do? Is there anything else I still haven't used yet? The other given. I have one more given, don't I? This given right here. So this given, so 5. It's angle AOB is going to be congruent to angle DOE given. Okay, so now let's see. AOB, so AOB is congruent to DOE. So that means that this one has 2 and this one has 1. What else could I do? Add another one. So that means that this is congruent here, right? And so therefore this one also gets a 2, doesn't it? Yeah. All right, so we're trying to prove that EOF, so EOF is going to be congruent to BOC. Okay, so now let's do the same thing that we did. Yes, go. So these are going to have the same finishing steps on this one, isn't it? Okay, so let's go with, so if I'm looking for FOE, okay, so FOE, so for 6, so angle FOE is congruent to, okay, FOE is congruent to EOD. and okay, EOD or DOE, same thing. Okay, angle is congruent to AOB. Then, what's my new statement going to be? EOF is going to be congruent to AOB. AOB right now. So, angle EOF is congruent to angle AOB. What property? This one is going to be transitive. So when you have a bunch of things like this, and then there's a then statement here, that one's going to be transitive because you're taking two knowns. Okay? You're taking two knowns and then coming up with another one from that. That one's going to be a transitive for that one. All right, so I'm going to have the next statement's going to be what do you think my next statement should be? If I'm finishing it the same way I finished the other one, EOF. So angle EOF is going to be congruent to angle BOC. And so what am I doing to this one? Okay, so EOF right here, EOF, right? Okay, I have EOF from this statement right here. Is congruent to AOB, but AOB over here is also congruent to BOC. So I'm replacing AOB with BOC. So that's where I have this. So this one is going to be a substitution. Hopefully I'm not boring everyone to death. Are we okay? Okay. All right, so let's, I think we have another one down here. Okay, this one's dealing with segments. Okay, so now for this one right here, let's start off with my given. It's going to be RT is congruent to WY and a semicolon ST congruent to WX. That is two things, but they're all my given. Okay, so RT. So that means from here all the way to here is congruent to WY, right? So those two pieces are going to be congruent. So that means that from end to end, they're the same length, aren't they? Okay, end to end, they're the same length. Okay, it says ST is congruent to WX. ST, get my tick mark right here, and WX right here. Yes? Okay, so now I'm going to do a little bit of math on this one right here. So it's going to look like an algebra problem on this. Okay? So I know that these two are congruent, right? So for right here, it's going to be, I'm going to make a statement that RT is equal to ST plus RS. Is that true? This is one that's actually going to pop up on the test. I know it is.
Damn.
Does that make sense?
Yeah.
Why?
Because both of those.
Both those together, right? So RT is actually both those values, right? Added together. So it's actually going to be from here to here is broken up into this piece and this piece, right?
Yeah.
Okay, so that's going to be that. So what reason am I going to give that? What reason does that look like right there?
Addition property.
I heard it.
Addition property.
Addition property, but which one? Looking at it right here. Thought I had it right here. I heard it.
Angle addition.
It's not angle, it is
Segment.
segment. Okay, this one's segment addition. Segment addition property. Okay, what else do we know? I know for line 3, I'm going to do the same thing for the other line. So I'm going to say that what?
WY equals YX, Y,
XY, YX
XY.
plus
No. XW.
WX.
Yeah.
We have XY from here to here, right? And we have to have WX, right? Okay, so. Okay, same thing. Okay. So now, I'm going to show you the next step and you're going to tell me the reason for it. What's going to be the reason for that one? Here's a hint. Isn't this RT? Oh, these are all congruent signs. Oh, dang it. I just noticed that. Okay. So, this one is RT, isn't it? And this one's WY, isn't it? Isn't this one over here WY? Don't we have a statement that RT is congruent to WY? Okay, and so what did I do with these values here? I did. It's a substitution. It's a substitution. I'm substituting it with something that means the same thing. So it's stated that these two go together, and this is a substitution. So I'm substituting RT from here with what we stated RT is equal to, right? Same thing over here. WY, I'm substituting with that what it's equal to with. Okay. Now, the next thing. So, I'm going to do this now. Let's see if you guys can figure out this one. So I'm going to show you extra work on this one here. So it's going to be ST plus RS minus ST is equal to YX plus WX minus WX.
So RS equals YX.
Okay, so this is the work that I'm doing. So my statement, okay, this is a lot of the work. I'm showing you what I'm doing. Showing you what I'm doing. So now this should be RS. I say S and I still write the wrong thing. So RS is congruent to YX or XY. You know, just to be honest on this one, I'm going to put XY. So what did we do here? What did we do here? This is all the work. I'm showing you all the work that I did for this statement right here. What did I do? No, I did not simplify. This is the work that I did. Okay? This is the work that I did on top, right? And this is my statement, because I would be able to just jump straight to the statement right here. And hopefully on the test it doesn't actually jump like that. It actually shows you the work. But what did we do here? What did we do to this? What did we do here? I subtracted. And if you're looking at this, at the very beginning, I said these two are equal, right? So if I said this is 5 and this is 5, what would I be doing to both sides of the equation? Subtracting 5 from both sides, right? And if I subtract 5 from both sides of my equation, I come up with the subtraction property, right? This one is the subtraction property. So for 5 right here, I'm going to say subtraction property. Are we okay? Yes, no, maybe? Okay, so let's take a look at, see, I think I have one more. Is there one more on the back? So, I want you guys right now, because these ones right here have the statements. These ones have the statements and missing things in here. So you guys, for this one, right now, are going to work on these two right here. You're going to work on these two right here.